Hello and welcome. Today on the bench I have this motherboard. It's a P5P800-VM. You might remember this motherboard. This belongs to another DTS XT10 I've got here for repair. And I don't think I want to make a video about this motherboard. No, I haven't really published the other XT10 video, but if I ever ended up doing it, this is probably going to be exactly the same fault. It just probably needs new capacitors. That being said, I don't see bad capacitors on this board. I might see some leakage on what I think are the VRN capacitors for the CPU, because obviously they are very close to the heatsink. And if you watch the video of the XT10, which is here on Patreon, the machine doesn't have any ventilation. So this area, I think it runs at silly temperatures for all the time the machine is running. The bottom line is, I don't want to bore you to death with me replacing one capacitor after the other one. I think this time I'd like to test it on camera. I tested it myself within the XT10. There's no signs of life, but I didn't really do much about it. I didn't plug a VGA cable. I didn't do anything. Number two, I think I'd like to visualize with the oscilloscope what happens to VCore when those capacitors are in bad shape, and potentially see the problem before and after. And I think I might skip the whole capacitor swapping if it ends up being a capacitor problem, of course. So we have this board. It's just out of the chassis as it is right now. It comes with a different heatsink. This is an Intel standard, rather those slim server-graded heatsinks, cooler. It's got this Kingston module. This is 256 megabytes of RAM, and that's it. Obviously, I've removed all the boards or anything. Let me plug it up, or plug it in. Actually, someone mentioned that on the channel. Let me plug it in real quick, and we'll see whether the board is doing anything or is completely dead. And then we'll try and fiddle with the oscilloscope and see if we can understand what's actually happening before just replacing components. Right, now I need to replace the power supply because this is all power supply. It doesn't have the ATX 12 volts for modern boards, so I'll have to get my... Oh no, it does it. And I have it. No, that's me hallucinating a bit. I thought this one didn't have it, but no, it does. This is the one we repaired on a video, I think, is the... Yes, Adrian. Well, no, I don't think this belongs to someone called Adrian. There we go. But that's the Pentium 4 friendly power supply. Right, so I got everything connected. Let me plug my postcard. Let me put some contact cleaner first, because it never works on these boards. Those slots are in horrible shape. You won't be able to see it because I haven't made the 90-degree adapters for PCI. But let's see what happens. Now, when I give power to the power supply, this might actually start. I think it's how it might have been set up to work with a silly little power board that I tend to remove when I'm refurbishing one of those units. But anyways, 3, 2, 1, go. No, okay, it doesn't start. So let me find the power pin, the yellow ones here, and let me turn it on. And it doesn't turn on. Why not? Hello? What am I missing? I've got a standby light there. Power button, yeah. Power LED power button. It was starting. It was just not doing anything. Let me guess. Screwdriver. Okay. What am I missing here? The fan is wired in. Well, I got the main connector here. I have the standby light in there. I have a speaker. I didn't check the battery, but it was working the other day. I mean, I gave power to the XT10. It wasn't doing anything. And did I give it power? I think so. Now I can't remember anymore. Now I'm questioning my own name. Power, yes. No, it doesn't work. Why? One thing that now honestly, I think I might not have powered it up the other day. The chassis intrusion is not connected because I got this one, let's say, in pieces. So I'm wondering whether without the chassis intrusion shorted, this thing refuses to even start. Right, so in order to disable the chassis intrusion, it's these two pins here. See what happens now. Still green. No. What am I doing wrong? I mean, I thought that that was starting and not doing anything. Now I'm now I'm really questioning myself. Now I'm thinking about I might have not tested this. Oh gosh, I can't remember that. But yeah, I mean, this is completely dead. That's interesting. Right, so, well, this turns out to be maybe a more interesting video. Maybe I should make an actual video about it. I'm sure the battery is completely dead. Yes. Let me try with the battery, though, I don't know. Yeah, let me try with another battery. Right, let's try this again. Power. And see if it starts. I don't think so. It doesn't. Okay. This is quite interesting. I mean, such a dead motherboard like this. I feel I'm missing something important. Because, you know, if you have bad capacitors, they shouldn't really completely prevent the board from starting. Yeah, at least the starting mechanism is pretty simple. I think it's this Wimbun chip here. All right, so, well, it looks like maybe this board was dead and I didn't really test it. So I'm like, okay, I had something in my mind and now it's completely different. And I went to test. So let me start again. I got out my thermal camera. I just wanted to see whether there was any activity whatsoever. Come on. And the board is in standby and I only see something there. There is I think it's a regulator. Everything else, there's something here. That's the network chip. It makes sense. It's actually doing something. There's something there. It could be, no, that's a reflection. But most importantly, the Wimbun here, the Wimbun chip, which is here, it doesn't really show any activity. So I thought, right, let's measure what kind of, I don't know, I don't really know where to start. I'm not sure I've ever had a board which was completely dead that wouldn't try to start. So I went here and checked the voltages here. And look at this. I mean, you can see from the analog meter at the bottom that something is trying to power up. I mean, I can change it to AC, but this is not supposed to be AC. I mean, it's reading 41 volts. That doesn't make sense. There's nothing. Is this supposed to be ground? Which one is ground? Ah, oh wait. So the chassis of my power supply is not connected to the same ground that comes to the motherboard. Well, we got 3.39. Okay, fair enough. So, right, we got 5 volts here and 3.3 out, I'd imagine. 3.1, I don't know what it is, but we got 3.3. I'm still confused that we don't have... Okay, we have a voltage between the ground of the power supply, 42 volts. AC. Between the ground of the power supply, the chassis of the power supply, and the ground of the output. Maybe I should try another power supply. Because what I've done, and I was in voltage mode, yes. I was, I saw that going up and down. And I thought, right, maybe there's something wrong with the 5 volt standby. And when I plugged my meter here into the 5 volt standby, this is kind of starting intermittently. Let me get another power supply. I mean, I'm giving for granted that this is working, but that was kind of a... Did I fully repair? Did I fully recap this one? Maybe, maybe not. In any case, it was kind of a crappy power supply. So let me get an actual, proper modern power supply. And let's see if anything changes. Because I'm a bit puzzled right now. Right, I'm going to try this one. It's not super powerful. How many watts is this? Wait a second. This is 110 watts. That's really not enough. Let me try. I think I have another one which is 270. Because the power supply I wanted to use is kind of busy with another board. I don't really want to start moving it around. And the only thing is, oh no, this comes with a 24 pin. Can I actually? No, I can't plug it in because that's the ID connector there. So, oh no, I'm running out of power supplies. All right, well, before I try like a 1,000-watt power supply I have in a box, in case there's something that wants to go bang in here, let me try this one. This is very low power, but it should be enough to at least try to power up the board if the problem was the power supply. I don't know, I'm really puzzled. Let's see what happens. I've been using this so many times. Again, it's just very low power. So not really expecting a lot, but we'll see what happens. Speaker back in. And yeah, let's give it power to this thing. Okay, power is in. We've got the 5 volts. Do I read 5 volts standby? I didn't check. I'm doing a horrible job of troubleshooting here, but it's kind of an improvised video, let's put it that way. Do I have 5 volts measured between black and... it's no... Oh, because I was checking the green wire. Green wire is not standby. Green wire is power on. So obviously I was powering on the power supply by probably feeding some stray voltage, which happened to be on the chassis. The standby voltage is the purple one, which is here. As I said, it's a horrible diagnostic here. We got 5 volts. Okay. Now, is this going to start? I'm laughing at myself. 3, 2, 1, go. No. Okay, so this is not starting. And what we're seeing before is I was basically starting the power supply manually. So this is dead. This is a dead motherboard. I'm wondering whether I should actually make a proper video, because I wasn't expecting this to be dead. I was expecting this to be the usual, I turn on, but I don't do anything. But now this is completely dead, and I feel it could be an interesting repair. It's kind of weird. I wasn't expecting this. They all fail more or less the same way. And so, obviously, you know, there's really not a huge amount of logic. When I turn it on, I'm sending a signal to the Winbone chip. The Winbone chip is powering on. So my only idea is either the Winbone chip is partially detached from the board. It has those little legs that can get detached, or it doesn't get the voltage. But it doesn't get the voltage. But I do see a 3.3 volts in here, which is definitely generated from 5 volt standby. So I'll have to find the data sheet of the Winbone and see whether it's getting voltage. I guess the first thing first is going to be a visual inspection. Chances are there's something broken on this board, like a broken trace. Probably that's all it takes. Right, so I had a quick visual inspection. I think I found the problem. I think I know where this problem is coming from. Let me try and show you, but in a minute we'll go under the microscope. Now, I hope the camera is good enough to show you that there is a broken trace on a very, very thin trace, which happens to be the power on trace. This is connected to the green cable on the power supply. So by cutting the trace, I guess effectively the motherboard is unable to turn on the power supply. I have a feeling that that is a factory mod from DTS, because DTS used to install these little boards on the front panel connector here, and this is basically to allow a rocket switch to be installed at the front of the unit. I mentioned that on the video, I guess, where basically I'd imagine back in 2000 and something where they developed those machines, they wanted an on-off switch. And on the previous generation of boards, which are A-open boards, my understanding is you could just turn on the power supply externally by shorting the green to ground, and the board would start up. There was no need to press the power on button. But when eventually I'd imagine that A-open board had become obsolete and unavailable anymore, they moved to the ASUS, and the ASUS needs a different sequence. So they couldn't just wire the switch, the front switch, to the power supply. So they developed this little board. What I don't understand is this is the first board out of 3 that refuses to power on. But I'd imagine what they were doing at DTS, they were cutting the trace so that then this board was in charge of turning on the power supply and not the motherboard. Because on the other 2 ASUS motherboards, I removed the board and I just wire the power on button, and it worked. So the fact that this is not working is, yes, of course, if the power on trace is severed, is cut, obviously it's not going to work. But now I'm wondering why some boards have the broken trace. At least this one has the cut trace and the other ones that do not, unless this is just like a very, oh come on, now got everything stuck. Unless this is just a coincidence and someone removed the motherboard and somehow damage happened there. It's just a bit too precise to be casual. Let's go under the microscope, because number one, I need to make sure that that's actually broken. Number two, I need to fix it, and that's way too small to fix it here. And also I wanna see whether I see signs of intentional damage, intentional cut of the trace, or whether someone dropped the board or something happened onto the, I don't know, but that should be the problem, I'd imagine. This is the power on pin. Let's zoom in and see what happens. And yeah, I would say that that is intentional. It's a very, very precise cut. Also, I don't really see anything happening nearby. So I really doubt that something happened to this board and something just happened to cut that very small trace with no damage whatsoever anywhere else. What I don't understand is why this board has this trace severed, which makes sense to me, don't get me wrong, because I've always wondered how the little PCB that DTS used to install on the board, how did that work with the fact that the motherboard is also trying to power on and off the board based on its own logic. So this makes sense to me, but I've done two more of these boards, and they were powering on totally fine once I've removed the little board and just powered through the power on button. So I don't know. I don't know. Chances are they didn't know that either. But anyways, they're not making this anymore, so there's nobody I can ask. But I'm assuming that once we fix that, I will be able to power on the board through the power on switch. I still feel that this board is going to be dead afterwards, as in it powers on, but it doesn't do anything, or it might be very unstable. We'll have a look. But first thing first, I need to fix that, so I'll get something to scrape off the solder mask, my very tiny little small soldering tip, and some copper wire. I get maybe this is okay. We'll have a look, and we'll fix that, and we'll see where we're going from there, I guess. All right, before I test this board, I'm wondering where the power on pin is going to. I'd imagine it's going to the Wimbun chip. So power on is the fourth from the right, first row. So that would be this one. I'm in continuity mode. Let's see if it's going here where the Wimbun chip is. Let me zoom in a bit. No? Ah, yes. Yeah, it's obviously the Wimbun is the chip in charge of turning on the power supply. So obviously with that severed, that's it. The motherboard, the logic is working, but the power supply doesn't turn on. And I'd imagine at that point it would be this little contraption's responsibility to turn on the power supply. Ugh, whatever. Well, let's let's power this on, and hopefully we get something out of this board, because then otherwise it's not a simple one. And I'm hoping, quote unquote, that it's also not working, as in it's not doing anything, and it basically needs a recap. All right, we're back to where we started. Let's give power to the board. 3, 2, 1, go. Right. Will it start? Let's try. 3, 2, 1, go. Yes. And no, we have signs of life. This is, yeah, I mean, it's probably the battery. I put the old battery in. I have it 00, so this is probably posted. And yeah, this is probably posted and then it fails at some point. Let me wire my capture device and we'll see what it's doing. And I guess I can run some software, see what it does, and we'll inspect the vCore to see what happens to it. You know, let's see what's wrong with this board, basically. Right, capture device is set, so let's turn it on again and see what it does. Yeah, it is posting. Look at that. And we have, well, no keyboard, blah, blah, blah. But yeah, it is trying to post to boot. So weird. I was totally expecting this not to work. Let me wire a keyboard and let me plug my IDE compact flash. We'll try and run Doom as usual, see if it works there. And then I guess we will go and poke around with the oscilloscope and see whether we find something wrong. Well, let me unplug my PC speaker here. Well, this seems to be working, to be honest. So, well, this will need a refurbishment, to put it away. Now I'm just curious to see whether, you know, this is maybe it's working now and then it stops working, it gets unreliable, maybe when it's warmed up a bit or after a while, or it's just not fully reliable. So let me go with plan A, which was the original thing. Let me get my oscilloscope running and we're going to probe around and see whether I can... Everything is a bit hidden in here, and obviously I have the heatsink, I can't really move it too much. Let me switch this off. Let me set up the oscilloscope. I'll set this up here on the desk so you can see it, and we'll poke around. I'm curious to see vCore. I think I see something under those capacitors, so I have a feeling that yes, this is working, but in reality, the moment you start using it, it won't work. Give me a minute. Right, I don't think I need anything running on this board. It just needs to be powered on. And here at the back, let me try and straighten things up a bit. Hopefully things are in focus. You can see this big plane. This is, from what I can see, it's a power plane. You see the three inductors, 1, 2, and 3. And that's where the voltage is coming. This is, I don't know if you want to call it like a phase design. So you have a couple of MOSFETs generating voltage for a split second. And then there's another set of MOSFETs generating voltage for a split second in like peaks. And the inductors and the capacitors are smoothing those peaks, and eventually the CPU is getting the voltage it's expecting. I don't know what's the voltage for this one. So on one end on the inductor, which is going to be towards the side of the board, it's the non-rectified voltage. It's the bad voltage. It's going to be should be just a pulse coming from the relative pair of MOSFETs. On the other side, you also have the small capacitors. All these ones, 1, 2, I think it's 3 and 4 and 5 and 6, 7, 8. These are all the small capacitors which is helping the inductors. The inductors are probably high frequency, the capacitor has more low frequencies, and they all together they smoothen the voltage. Now, if the capacitors are not great, the voltage on the power plane, the internal power plane, which is the one that goes to the CPU, it is not going to look nice. So let me turn this on, which is going to be challenging. I don't know where the power on thing is. But first, I guess I need to power on the power supply. Yeah. And this is the fan, of course. So I can't I can't keep it this way. I need to find something. Right, so I got the oscilloscope in DC mode. Let me put a full screen. There we go, so you can see something. And let's see what kind of voltage we're getting here. Well, we're getting 1.37 volts. There's quite a lot of noise, but that's also my very long ground lead that is picking up all sort of noise. So, but it doesn't look too bad. Now, I haven't got easy way to control the oscilloscope from here. It's not. I mean, this is longer time base. It doesn't look too bad. Obviously, there's quite a lot of high frequency noise, but that's 100% my lead. Let me see if I can use an actual proper ground lead. That should make the signal much clearer. I was expecting something horrible, to be honest. Right. Yeah, this is so much cleaner, but it's also fine. I mean, if I'm going into AC mode, I mean, this is 200 millivolts. I don't think we have an issue here. Obviously, I can check all the other inductors. They're all connected together, so obviously it's going to be fine. So maybe this board is actually working totally fine, and it's not. I need to check. I mean, a friend of mine sent me this board, and he can't remember what the problem was. But I think he said the board was not starting. So I don't know. Again, it needs to be refurbished. It needs those capacitors replaced. But I don't see like an obvious issue here. What happens if I'm checking the other end of the inductor? We should be able to see the phases. Come on. And I'm not sure how clear it is from up there, but yes, you can see the phases. If I had I do have an oscilloscope with 3 channels, but if I wired all the 3 channels, you would see that these pulses happen at different time. So they don't overlap each other, but obviously, if I'm moving my probe to another one, they will look exactly in the same place because the oscilloscope is centering everything. But yeah, everything seems to be pretty healthy. Phases are fine, and once again, on the other side, most importantly, now obviously resolution is pretty low, the voltage seems to be fine. But yeah, it's everything is working as it should. So, oops, thankfully, I didn't short anything. Once again, I feel that, I'm sure that those capacitors will need to be replaced, but there's nothing obviously wrong on this board. I'll try and stress test it a little bit, maybe off camera, and then I'll come back if I see something. But the board seems to be working totally fine. It definitely needed a little mod, because I'm going to remove this horrible contraption. It's just another thing that can break. I don't need it. Most importantly, it's better for Linux, because by sending the momentary turn off button at the pulse at the end, you are instructing Linux to turn off gracefully rather than removing power, which I guess, how can I say, you can kind of account for while you're designing the software. I feel it's never a good thing to just pull the power from a Linux computer, especially from 2000 and something. So yeah, this is working totally fine. Well, let me do some stress tests, but if I don't find anything, I don't see the point in continuing this video. I'm glad I've done it here on Patreon, because it would have been like, okay, what's the point in doing this? Yes, I can recap the whole board just for the sake of recapping it, but I don't have a before and after to show you. I know it's going to be good for the board. I know it's going to be good for the DTS. It's going to be reliable, but I don't see a major problem here now that I can show you right now. So let me do some poking around, and well, I'll come back to you anyways. Now I'm about to run the time demo of Quake. I do see a little bit of bumps on the line. I'm using the short probe, so this should be maybe not the best case scenario, but not too susceptible to interferences. If I'm running the time demo now, it's loading. Yeah, it's running now. Don't see much, and I'd imagine now the CPU is probably being used 100%. It's kind of slow, so, and the time demo, I think it removes any frame rate limitation, so it's running the CPU flat out. Well, I guess there's also some graphic involved, but this is all, there's not a GPU, so all the processing is done by the CPU. It doesn't look too bad. I mean, I can see the voltage is jumping a little bit. I mean, if I want to ignore those little bumps, the voltage is not completely stable. I'm not sure if I can maybe visualize it with the roll mode. This is roll mode with resolution at 200 millivolts. I don't see a lot, so maybe, yeah. I mean, you can see it's a bit dirty, of course. I'm not sure. Maybe that is the issue. I have no idea. But I'd imagine when you have switching supplies, that's why switching supplies are not happy. They don't live in sound devices, because you always end up with all sort of interferences. And I'd imagine the CPU can deal with that. But also, even my short ground lead is able to capture those high frequencies interferences. Ideally, you want one of those probes with a little metal pin, so you have a very, very short run of ground, which I don't have at the moment. So I'm curious to see after I recap the board, I'll run the same test and see if by any chance this is any better. Because back in normal mode, yeah, I can see this, the voltage is slightly jumping, but we are talking about one division is 200 millivolts. Now the demo is finished, but this is happening anyways. One division is 200 millivolts, so we get, I don't know how much, 50 millivolts of ripple maybe? I don't know, I don't think this is a problem, so kind of surprised that this board is giving trouble. Unless, once again, after 24 hours run, or maybe it's just unreliable every now and then. And once again, these would run movies in cinemas. You can't just afford the thing to crash. Even once a month, it means refunding people. So ideally, you want this to be as reliable as possible. I mean, 100% I see juice under those capacitors. So I'm surprised that this board is working. Obviously, it's covered in dust right now. I'll take some video with my iPhone. I'll just put it on screen right now. So, well, this is working, but obviously this must be unreliable. I'm surprised it's running Quake, it's running Doom. Again, the DTS software is very low power, so it's kind of weird. Obviously, this needs a full recap, 100%. But I'm very, very surprised that the board is starting regularly. I can run software, like heavy software, and it seems to be working totally fine. But anyways, let me recap this board, and then we'll do some tests at the end. We'll check the vCore again. Chances are the vCore is going to be so much cleaner after it's been recapped, and that would explain why I got this board on the desk. Right, let me do the recap. I'll come back to you. All right, it's the following morning. Capacitors have all gone. I've repopulated the board with new capacitors, but they're not soldered yet because I wanted to show you something. So the small vCore capacitors, which I've now replaced with this red Wurth one, they were all gone, completely like exploded at the bottom because they are small. So the lid of the capacitor is at the bottom. They are completely exploded and they don't read anything. I've got this one as a test. I think this is one of the best one. It's reading 4 microfarad. And this is supposed to be a 680. Yeah, 680 microfarad. This is completely gone. What does the ESR say? I mean, the ESR is 50 ohms. This is gone, and the others are not reading anything, so happy days. Then I thought, if those capacitors... I can't speak today. But then I thought, if those capacitors are completely gone, why on earth wasn't I reading like a massive ripple on the oscilloscope? And how come Doom was running, the system was posting? I mean, I didn't really test it a lot, but it seemed to be working totally fine. So this morning, before soldering things and everything, I decided to have a little tinkering to understand things a bit better. And I think I've discovered something I wanted to share with you. Now, you can see from the top of the PCB, the power plane, the vCore power plane, which is this orange section, which obviously it's orange solder mask, but it's a sheet of copper. You can see I've removed a couple of 3 capacitors here. This is where one of the vCore red Wurth one, the 680 microfarad would go. And you can see that one leg, the one marked with the white section, that's actually the positive. I keep thinking that's the negative, but that's the positive. That is on the power plane. The other leg is on ground. I can show you that if I'm probing the other leg, it's reading 0 ohms when I'm checking with ground. Now, the other leg, the power plane, the CPU is in. So obviously, this is reading the resistance, internal resistance of the CPU. 2.7 ohms is not short. It's totally fine. Capacitor went on the floor. It's totally fine. When it comes to RAM and CPUs, GPUs, the resistances tend to be very, very low. So that's totally fine. So obviously, if I'm checking one end of the inductor, it's going to read exactly the same because the inductor is delivering these voltages, these 3 phases of voltages onto the power plane. Inductors is like swimming in oil. The inductor doesn't like sudden voltage changes. So when you feed those little pulses I showed you yesterday on the other end of the inductor, you have something which is much more smoothened. And then you have this set of capacitors, which are 2 per phase, which are doing the rest, and they are delivering the perfectly flat and stable voltage to the CPU. But if those capacitors were completely gone, how come it was still working? How come what was reading on the oscilloscope didn't look too bad? So if you follow this orange power plane, you can actually see that it's going down to here where this 1500 microfarad capacitor is. And there is one on this end as well. If I remove it temporarily, come on, come out. There we go. It's in between. I don't know how much you can see that, but it's in between one pin, which I'd imagine this leg is going to be ground. Well, it is ground because that's the non-marked side of the capacitor, and the marked side of the capacitor is going to be 2.7. Yes, that's the power plane. And the same is here. We go ground on one end, and I guess it's this one is going to be 2.7. Yes. So it wasn't just the 680 microfarad capacitor. You also have these 1, 2, 3, 4 1500 microfarad capacitors. Now, these are the 1500 I got from the board, and if I check them, they don't read 1500 anymore, but they read something. They read 800. So it's like half of the capacitance. And the ESR, I would say, no, it's not making great contact. The ESR is pretty low. It's 47 microohm. So they're all like that. This is another one. I don't see signs of like leakage of those on those capacitors. This is reading, again, half of the capacitance, but 60 milliohm, which is probably kind of high. I don't know. Let me check. This is the brand new one, which I was going to install. That's an FR Panasonic. So this is supposed to be a good one. Let's see what it reads. It's reading 1.4 millifarad, so more or less 1500 microfarad, and 39 milliohms of ESR. So it's not far away. These are very low ESR. They're not far away from the existing ones. So the existing ones, they were almost dead, as in capacitance was almost gone, because half of it. But the ESR was good. And when the ESR is good, well, it means like it's acting like a 700 microfarad capacitors. And I'd imagine that was enough for the V-core to be stable enough to actually function. But I'd imagine this motherboard was going to be very, very unstable, especially after some time. Now, what I don't know, I can have a look, but if someone knows about it, if you can let me know down below, that'd be great. Because I see that all the time. Why do you need different sizes of capacitors on a circuit to offer the best performance option? I see that all the time. You have like I don't know, 1000 microfarad, then you have the 220 microfarad, 10 microfarad. So in this case, why do you have a number of 1500 microfarad, but then you have the 680 microfarad as well? Do they like tackle different circumstances, like the smaller ones? Maybe they are, I don't want to say horrible things, stupid things. Are they faster? They react better to faster spikes, while the big ones are like a big reservoir. So if the CPU is drawing more energy, suddenly the 1500 will be able to deliver that energy, while the 680 will take care of the smaller ripples. I don't really know. I can have a look online for sure. But clearly the 680 were all gone. And the board was only working basically on fumes with the 1500 microfarad. That's quite interesting, I have to say. I don't know, I wasn't expecting looking at those capacitors, the state of those capacitors, the 680, I'm shocked that I could run Quake and Doom for like 15 minutes without, and the thermal paste is completely dry. Now this is a Celeron, I think. Yeah, it's Celeron, it's very low power. This probably is going to work without a heatsink. But yeah, it's quite interesting. But obviously, clearly, this board needed a full recap. Now, when it comes to the other capacitors, basically, I think there are like 3 types of capacitors, 4 types, 5 types. But the most used capacitor on this board are these little 820 microfarad. They're a bit everywhere. And I think this is actually reading, I can't remember. I mean, it's reading 460. Again, they're tired, but they still work. 400 is more or less half the capacitance. I think yesterday they read a bit more because they were just out of the board, and out of the board they were hot. And when you warm up a capacitor, I can show you now, they will regain the capacitance. I think it's just a physical effect that the electrolyte warms up, and somehow it performs better than when the capacitor is cold. And that's why some devices with back capacitors, they might not work when they're cold, when the board is out of the box, but you turn it on, you let it run for 20 minutes, and then suddenly the board starts and comes back to life. I've got this 1500 microfarad capacitor connected via leads to my component tester. Obviously, this is not an accurate reading, but that's not the point. So it's now reading 830. Let me warm it up. I got my hot test station set to 250 degrees. And let's see what happens. What happens? 828. Let me warm it up. 30, 40, 50, 60, 70, 90, 900. $1,000. There we go. It basically regained full capacitance, 1.4, where's that, millifarad, whatever that is, 1500 microfarad. So this is back to, and the ESR, it's a bit high, 132 milliohms, but this is working now. So that's why I'm using hot air very often to test things, because with this one you can identify whether it's a capacitor, it's something else, and obviously if I'm cooling this down again, it will actually keep the capacitance for a while. It's just a few seconds, it's slowly going down. What kind of temperature? It's not scorching hot. It's, I can keep my finger on it. It's probably like 55 degrees or something like that. But if I cool it down, that's quite interesting. It takes a while for the capacitance to go down. It's not an instant thing. But eventually we'll go down to, yeah, there we go. We started at 800, something like that, so we are back there. Very, very interesting. Let me go ahead. I'll double check that all the capacitors are in the right place, all soldered. And I guess I'll see you once I've got the board finished. We can test it and we can double check that V-core with the oscilloscope again and see whether we can spot anything. Right, board is done. You might notice the fan is missing. I'm decided to dismantle it, probably not the right time for doing it. I want to see if I can change the bearings, but that's another story. It's a Celeron, very low power. I think this should work probably for quite some time with just the heatsink. Eventually I can put a fan on it for testing, but for now, let's make sure that it works. Let me replace the battery since I'm here, removed it because it was on top of the preheater. When it comes to capacitors, I've checked them multiple times, but you never know. So let's see if it does anything. Obviously, we won't see the fan spinning. Let's turn on the power supply. 3, 2, 1, go. We got a green light in there. I have my postcard, which you can't see, unfortunately, so I'll have a look myself. 3, 2, 1, go. Nothing. Dead. What am I missing? Oh, maybe it's just my... Okay, this is a bit dirty. Let me grab a screwdriver. 3, 2, 1, go. Yes. Okay. Oh, there's no RAM. That's a good start. There's no RAM. That's a good start. It's alive. Where did I put the RAM? That's a good question. And I found the RAM. So let's put it back into the slot without cleaning it. It's never going to work, but we'll try. Standby power. Tweezers is useless. And 3, 2, 1, go. Yeah, it's doing something. Yeah, posting. Happy. Unhappy with things, probably won't feel the fan running, but yeah, it's running. It was running before, appreciate that, but it's definitely running. And I've replaced the thermal paste, of course. There was quite a lot of thermal paste under the heatsink. Obviously, it was like solidified, fully solidified. Well, it's doing something. Yeah, I can definitely see the heatsink is getting warm, so it will need a fan probably pretty soon. Let me grab set up the oscilloscope again. We'll check that V-core again. I'm curious to see whether we see any difference whatsoever. Because the board, once again, it 100% needed a recap. Oscilloscope is wired in. Let's give power to the board. It's started already. There's no fan, so I'll have to keep that in mind. Let's see what we're reading. This is as I left it yesterday, 200 millivolts on DC mode. So let me probe V-core. And I think it's the same. I actually see some extra spikes. Probably, I guess it depends where the main power supply is. I'll do a little comparison in post-production, but I don't see this massive improvement. It's still jumping up and down altogether, plus I have those little dips. This is with 500 millivolts per division. It's the same voltage, otherwise the CPU wouldn't work. I don't see an improvement here. And obviously the board was working, but it was working with, I would say, a third, less than a third of a capacitance, like a fifth. I'm wondering whether this is a Celeron. It's a relatively low power CPU, so this amount of capacitance, the amount of capacitance left was enough for a Celeron until, again, probably was borderline, and eventually it would fail, it would reset, shut down, crash, that kind of stuff. The moment you install something a bit more beefy that requires more power, sudden amount of power, instant amount of power when you're playing a game or something more powerful, well, then obviously that amount of capacitance is not required. I'd imagine that the amount of capacitance there is now on the board is probably oversized for everything. I'd imagine you probably need half of it, and the designers, they just install twice as much just to account for anything. But yeah, I don't see the improvement. I'm wondering whether, has that got better while I was talking? I mean, I compare with what I have from the video, from yesterday's videos, but it's still jumping a bit, and I still have those blips. Even though the ground lead is very short, well, it's still there, and obviously it catches something. That's it, I guess. Well, the board 100% needed a recap, so that was out of the question. This is hopefully going to work for quite some time. And did I fix something? Yes, I fixed the board. The trace, that was kind of weird. I wasn't expecting it. I'd imagine I'll have to look for it on if I ever get another XT10 for repair. I'll have to expect that the power on trace is going to be severed for whatever reason. What I'm going to do now with this board, I'm going to replace the thermal paste under the nose bridge. And then what I was doing, I was basically trying, actually now I'm thinking about it, I see those like glitches, the blips with the power supply switched off. So this is coming from the ground of the board, I guess. If I remove the ground clip, it goes away. Oh, that's very interesting. I'd imagine that that's coming from the power supply. After all, I believe there is a small switching mode power supply inside this one, which is generating 5 volt standby. I'd imagine, yeah, if I unplug the power supply, it's unplugged now, in a few seconds when 5 volts goes away. Well, no, the power supply has been unplugged for a little while. Oh, okay. I think it's going away now. It's got better. Is it just me moving things around? Well, it's not going away 100%. It looks like it's something picked up by the ground. I don't know. I don't understand. I'm not connected to anything. So the ground of my oscilloscope is wired to the board, but the power supply is not connected to anything, and there's nothing else connected to the board. So, it's probably picking up some interference. I'm wondering whether it's my studio lights here. No, it's not the studio lights. And my laptop is not... Oh, yes, of course, I've got the laptop connected to it via VGA. There you go. So most of the interferences we were seeing that were coming from the laptop, really? Let me plug the power supply again now, and there's nothing. Okay. Oh, gosh. Okay, 5 volts in 3, 2, 1, go. And it's actually started. Yeah, that's kind of the high frequency noise I'd expect from a switching mode power supply. Let me probe the V-core again. Yeah, I'd say I was probing the laptop power supply noise or whatever. I mean, obviously now I have this high frequency noise. Now, unfortunately, I can't compare with how it was yesterday because the board is kind of fixed. Interesting. Let me put it back to 200 millivolts where it was before. That's it. And again, I'd imagine the high frequency noise is kind of unavoidable with switching mode power supplies. That's why they're not great for sound devices, but it's much more stable than it was before. So the noise I was seeing yesterday and earlier on, it was somehow the VGA connection. And I'm sure that if I touch the shield of the VGA with the shield of the motherboard, there you go, it comes back. Look at that. And once again, I'd imagine that is the power supply of the laptop. Amazing, right? So, well, what we learned from this, that noise when probing with an oscilloscope is always difficult to ascertain, to track down, and to remove mostly. And what I'm still puzzled about is there wasn't a massive amount of ripple yesterday. There is obviously none today. We couldn't probably, if I had removed VGA yesterday, we would have had a better picture. But yeah, the board seemed to be working fine yesterday, even with very small leftover capacitance on the capacitors. Let me turn this off. The heatsink is getting hot. And I guess that's it. What I was saying earlier on, before I realized that the noise I was probing was something else. The next step for this board, which I might have shown in the other video, would be to remove the Northbridge heatsink and replace the thermal paste. There must be some thermal paste. Then what I was showing, yes, I have disassembled the fan. Because what I'd like to do, I'd like to replace the bearing. I'd like to replace the fans as a standard on these boards, because fans, they don't last forever. Bearings don't last forever. So I don't see the point in replacing all the capacitors and everything and then reinstall a fan which might have been running for, you don't know, 50,000 hours or whatever. Maybe I'm being overcautious. Yeah, a drop of oil might help, but I'd like to replace the fan. Intel fans can be replaced. You can't just find the plug-and-play fan that goes on the heatsink. So I didn't want to throw everything away. It's a decent heatsink. It is very hot now. And I realized that you can actually remove the bearings pretty easily from this type of heatsink. Where is the rest of the heatsink? I don't know. From here, it was actually pretty easy to just push out the bearings. So I will try and source 2 new bearings, fit them back in. There is a little clip in here, which I might try and find replacement just in case. And then at that point, there's no consumables inside the fan. I mean, the shaft might worn out, but this looks in good shape. Everything else is basically the bearings. The bearings eventually will fail. And it might not just be because it's been used so much, but this is like 10, 15 years old. The grease is probably dry, or it doesn't touch the ball bearings anymore, and yeah, that can fail. So I can definitely find these bearings. I'll replace them, and I'll call it a win. And then I'm going to reflash the BIOS, as I did with the other one, just to avoid that the board in 6 months' time develops the bit rot. We have a new battery anyways. That's it for this board. Yeah, I will test it with, how's it called, memtest for a while, and then it's ready to go. So, kind of unusual video for me. Maybe I should have posted this on the main channel. I don't know. I mean, it's too late now, I guess. And this is going to be an exclusive video for Patreon. I do appreciate your help, of course, and I'm hoping that this video is going to appeal more supporters over time. And with this, I'll continue working on this board, bits and bobs, but nothing really worth showing on camera. And it's Sunday here, so I'll wish you a great Sunday, but obviously I will publish this video another day, so I wish you a great week or something, and I'll see you next time. Have a great day. Bye-bye.